Good morning and welcome to another great session about KServe and VLLM, because I think that it will be at least the third session I've seen on the agenda about those topics. So I think that are interesting topics. Just a note, this session was intended to be a breakout lightning talk, but has been promoted as a breakout, so it will last a little bit more than 10 minutes, like I think it is already on schedule. So I'm not Maria Vittoria, as you can figure out yourself. She was supposed to be here with me, but she had a little last time issue, so she won't be able to fly here with me. And so you have to be happy just with me. And we will try to talk about why and how we can improve the inferencing with KServe and VLLM. I'm Matteo. I'm a specialist solution architect in Red Hat, and like Maria Vittoria. Just to give you an idea of what we do in Red Hat, as a specialist solution architect, we are the tech people that talks with customers. So we are the one that talks about architecture. We validate solution, and we validate the application that the customer is doing. And it is quite a fine time to be in this role, especially when you have to talk about AI, because as we listen, even during this day, there are projects that rise and fall during the night, and you are supposed to know everything of them. So this is why my hair are gray and the bird is gray too, because it's not easy to be up with the pace of this project. So why should you care about KServe and VLLM? It's a great question, I think, in this moment, and thank you for asking. I've tried to ask this question to an anchorman we created inside our team. It's just a joke, just to break, just an icebreaker, but we set up a prompt to an LLM to be a cynic and a bit rude anchorman, and we asked to him, why should I attend this session about improving inference with KServe and VLLM? And his answer is, a bit cynic and okay, if you want to attend and if you want to optimize and trying to discover something that maybe is not so painful, you can attend, but okay, it's up to you. This is really simple to get. I don't have the chatbot running now, but if you want, I can show the prompt after the session. It's quite easy and funny to use during the events too, as an icebreaker. But really, why should we care about KServe and VLLM? I don't know if I have the real answer. I think I have some reasons in this presentation we prepared with Maria Vittoria about why you should care, or at least why you should care about serving and inferencing models outside the cloud. We put this picture because I think we heard even this morning in the second keynote, as today is quite easy to deploy, to serve a model or use or consume a cloud model, but why we should think about this project? Let me go straight. If you are a data science engineer, you maybe develop your own model, so you write your model, you train your model, and at some point in time, you probably will need to deploy your model somewhere, because having trained and developed a model is cool, but if nobody is using, it's useless. So you may share this model and let other users use this model inside the program, like as a library, or you can serve this model, you can expose this model to your customer, to other colleagues, to someone that may need to use the feature this model has. And we will see later how we can do it with the KServe that is already mentioned here. Or maybe you're just a developer and you want to improve your coding capabilities and you want to deploy an LLM that could be able to help you. So the process is quite similar. You are not training the model, I hope, because there are a lot of models out there that are already ready for that. You just need to provide an infrastructure in order to deploy the model and then access the model and use the model. So this is quite simple and quite the use cases that you can have. Why care? Coming back to the question, why I care about KServe and VLLM? Because of course they are open source projects, and I hope you listened to the keynote this morning when Manos was talking about open source models and why they are important, open source AI, not to be bound to what the private companies are doing. So open source is the place where the innovation happens, and then I have a little statement about that later. So thanks to the Linux Foundation, we are trying to have a governance of what's happening, because there are a lot of open source projects, and an open source project is not just because it's open source, it doesn't mean it's good. So we have to find out the way to navigate through this sea of projects and features to understand which is the right project and the best project we can use. It's not easy, but we have communities that do that. We have Hugging Face that is plenty of model we can just download and use and try, so we don't need to use the proprietary models. And also, OpenAI has just released GPT-OSS, like the open source version of ChatGPT. So we have really a lot of options, and I think that is the right time to try this option, because it is important to not to be bound to something that someone is pushing from the private companies, but using open source software to build our own AI. One thing I want to highlight is that I've said a lot of time, but it is important. There are really a lot of projects that rise and fall during, maybe not the night, but within 2 or 3 months. At the end of this presentation, I've added a couple of slides about a project that when we submitted this call for paper doesn't even exist. So it's not easy to find out the right project and the right project that will last. So we have to stay close to the communities and understand what's going on, which is really, really important. And I think I am a developer since 20 years now. And I've seen that we, in the development, usually we fall in love with stuff. And usually it's the stuff that works, and we try to use the stuff to do everything. And I think that is a big mistake to do in this phase. We have a lot of tech tools that we can use, but we should avoid to fall in love with a project, a technology, just because maybe we found out that work in a project, because the world is going so fast. It really is going fast, and we have to keep up. So to give an answer to the question, why should I care about KServe and VLLM? For me, is because now they are the most interesting project, the most stable project, the most used project out there. But we have to keep in mind now. So maybe within 6 months, we will have other talks talking about other projects, because there has been a new technology out there that maybe is more outstanding and more capable than this project. I took a screenshot from the keynote yesterday. It's not the best photo I ever took, but I was impressed about that number that says that 63% of organizations already use open source AI models. And I would like to ask you if you were surprised like me, or if you feel that is something that is going on. How many of you are already using open source models in your company? Okay, it's not 63%, just. No, I was surprised because really I talk with customer every day about application, about the AI, and often the hardest conversation is not about which technology, but why should I use an open source model when my legals told me that it's fine to use OpenAI, just to mention one. I think that we are on the right path. It could be a long path to get there, but maybe, as I heard in other speeches in the conference, maybe regulations, maybe cost will help us to go down that path. Because quoting again Manos in the keynote this morning, I think is right. If I want to build something mine, I would have to choose open source model. Otherwise, I should just talk to ChatGPT and I am fine. So I hope that within time we are going to go down that way. And for sure, here at Red Hat, we are there to help building all the platforms, all the tools that people need to run this open source model. Of course, because we work within communities, we develop projects in order to achieve that goal. We will see maybe next year here if this percentage will still be 63 or it will be increased or whatever will happen within the next year. I'm quite curious to understand that. So going back to the content of the speech, I think that you already seen in other presentations, but KServe is a project that is a way to handling AI workloads on Kubernetes. So obviously you need to have a Kubernetes for running your model. And I'm not saying that makes it very easy, but quite easier to deploy a model within a Kubernetes cluster. At the end, what I think we are trying to do as a community is trying to serve and deploy a model like an application we are used to. At the end, we deploy a container within a Kubernetes cluster. It has different characteristics, different needs, different resources. But at the end, the idea is to try to deal and to serve models like an application. At the end, if you think about it, if I have to expose a model, expose an API, an endpoint, it is not too much different that expose a Java application or a traditional application. It's just different, the content that I'm trying to expose. The great thing about KServe is that it's good for exposing both traditional predictive ML AI workloads and LLMs if we want. So it's very powerful and very flexible in order to deploy whatever you want. One of the features that for me is really nice about that is that you can leverage the KServe functionalities in Kubernetes, so you can deploy your own model in a serverless way. So if the model has traffic, the model is up and running. If nobody cares about your model, the system will switch off the pod, and you won't consume the resources that are allocated for the model. Another great thing is that you can pack more than one model within a container, within a pod. So you can have, if you have, for example, small models that does not require a lot of resources, you can pack multiple models within a pod and run it within the same runtime, saving resources like RAM, CPU, and so on. And obviously, this approach maybe is not as good as for deploying an LLM, because an LLM basically is big and it takes time to be up and running. So maybe this is something that works very, very well with smaller model and traditional model. Out of the box, you can see that the KServe is able to deliver and to serve all this kind of models, so it's quite flexible. So the next step is VLLM. VLLM was meant to try to scale and manage the LLMs in a better way inside Kubernetes. It's a project that is not so old, because it's up there since a couple of years, but has gained rapidly a great reputation, and is going to be, or at least it is the de facto standard when we have to deploy LLMs on Kubernetes. I saw during the keynotes and other presentation a lot of companies mentioning already VLLM, so it's there, and I think it could be there for a while. Why? Because it's something that is built with open governance, with model support. It is really a lot of features, and there is a lot of hardware support. Has been said yesterday in the keynote, remember that one big challenge as for now for AI is not the models, but it's the infrastructure. We have to have a good infrastructure in order to deploy models safely and in a manner that really works. What I was saying is that VLLM is really built via the community-driven approach. We have models creators, vendor, cloud provider that are really contributing into that, because almost everybody around is using VLLM. Even I don't know if you deploy a model on Google Cloud with Vertex, they are using behind the scenes VLLM. So it's something that the community, the broad community, is really working on, and I think it's one of the reasons that it's succeeding, and why we should really care about this project, because the community is broad, is widely approved and used. So there are a lot of models that the project is supporting. So you can have transformers, mixer expert. You can just grab models from Hugging Face and deploy it in your Kubernetes environment. And of course, a great thing is the power of the community. If you, I don't remember if you remember when DeepSeek came out in February, the day after, or maybe the same day, depending of your time zone, you were already able to deploy DeepSeek with the VLLM, and the same has been for the OpenAI open source version. The next day, you were able to deploy on your infrastructure that model with VLLM. This is really because of the power of the community, because people are working closely on it and developing this kind of feature. Here we listed just a lot of features that VLLM has. I think that one of the most important feature is about the compression. With VLLM, a great benefit that you have is that you really can save resources, because VLLM has these mechanisms to compress the model, and it's able to let you save memory and resources when you run the model. So it's not just optimizer for inferencing, but it also helps you to save resources, which is something that is not bad as of today, because everything we deploy, we are paying for that. So quite a nice use case. As I said before, the hardware support is very heterogeneous. Basically, you can run it everywhere, on every hardware, on every cloud provider. It basically just works. And the great thing is that as an open source project. If it's hardware is missing, or a provider is missing, or a model is missing, you can contribute and evolve the project. So something that I didn't mention before, maybe I think that is something that being an Linux Foundation event maybe is just something that it's obvious, but open source software is not just getting benefit from using it, but it's also contributing. So if you feel that there is something that is missing, something that you need, the greatest way to achieve this goal is to participate within the communities. And if you can, and if you are able to work with it, to contribute and to evolve the projects. Why I was saying that a great thing about VLLM is quantization. This framework is good for in quantizing the models. So as I said before, it's able really to save you space in memory. If you think about deploying a model maybe that requires a lot of memories, maybe 100 gigabytes of memories, and okay, it's fine if I deploy one instance of my model, it's easy. But if I want to deal with my model at scale, maybe I need 10 instances of the model. Saving resources is starting to become an important thing to keep in mind. So this is very important. And here this is we have put some numbers showing with the difference of the throughput that a model can achieve with quantization. So it's something just to give you an idea. And basically, this is how the compression tool works, very at a high level. So just to give you an idea of how the compression mechanism works. But what I don't expect that you trust me just because I'm speaking here. So, if you go to Hugging Face, there is the Red Hat AI page. There are, at least yesterday, there were 510 models. You can go and grab one of these models. They are models that are already optimized by us. So you can just go there, download the model and try it and see if there are differences, if you see advantage of using it. And of course, the quantization maybe will mean that you will lose a bit of precision. But something that has been said already this morning, probably for the most use cases that we are dealing with, we don't need the full capabilities that a model like GPT-4 or 5 has. We may need just a model with a very good foundation, and then we need to enrich the model with our information. It's the best way to build our model. So this is the project I was mentioning before that was not even here in April. So it's almost 4 months old. And it's LLMD. It's a project that aims to, I give you in the presentation there is the link about the community project if you want to go there and look at it. It's the best way to start to understand how it works. This is a project that aim of this project is to try to manage LLMs at very, very large scale. So it's very specific to big infrastructure. It's something that is not very easy, but the idea is to have a pool of models deployed in our infrastructure and having intelligence routing to route the request to the right models that may be looking into the context of the request or also looking at the status of our infrastructure. So routing the request to the right instance, maybe that is the one that has more capacity in that moment. So it's a very interesting project where there are a lot of companies that are working on this project. We have Carol here that if you want, may connect to the community VLLM. So if you are interested to understand how it works and how you can participate to this project, you can do it. So just because I'm out of time, a few things about Red Hat. We work on upstream projects. Then usually what we do, we make a middle project that is Open Data Hub, that is where we try to put all the project together and build something with the single project. And then this project become OpenShift AI, which is the product that our customer use in production. And if you want to give a try to the things that I've told you today, there is this fantastic opportunity to use a developer sandbox, which is basically a Kubernetes namespace in a shared instance. You can sign up and you have the access to this environment for 30 days. And after 30 days, everything will be deleted, but you can subscribe another time. And you will also be able to deploy models, so you can try out KServe, VLLM, and so on. You won't have GPUs because we are not charity, so they cost a lot. So you will be able to deploy maybe simple models, not big VLLMs. So, but if you want to try it out and go deep in the things I told you today, you can go. And that's it. Thank you. So if you have questions, I'm here, or I'm around, so you can reach out.
Please show the QR code here.
Yeah. Please.
Have you heard about VLLM production stack?
No?
I think it's like an alternative to LLMD and also KServe. So LLMD is like the alternative to KServe, right?
Let's say it's an evolution of KServe.
Model scaling and
yeah, it's an evolution that is trying to find the best way to go with very large production environments and so on. As I said, it's not easy at this time to understand what will be the best solution to deal with them, and we have to keep to make some choice, experiment, find out which is the right solution, but also be ready to understand if we are on the wrong path and maybe try to change something. I think that maybe LLMD will be something that we will heard a lot during this year. So maybe it will change something that we are used to use now, because maybe it's going to improve and become also a great solution for smaller deployments. So we will see, as I said at the beginning, within a year what will happen in this world. Also, less than a year, 6 months could be already a long period. You're welcome. Yeah?
KServe and Triton, do they have some common functionalities?
Yeah, I mean, Triton is the runtime that you use to run your model, and basically with KServe you can also deploy some Triton model, some models that works with Triton within Kubernetes. So I think it's a level under the KServe framework. So KServe is the best way to handle the deployment on Kubernetes. Triton is the inference engine that is developed by NVIDIA. So,
thank you.
You're welcome. Yeah?
You mentioned using KServe and Knative. Probably you can use scale to 0.
Yeah.
And you also mentioned that it's not good, like for large language models, to like scale to 0 because it would like take a lot of time to load them into GPU memory.
Yeah.
Do you know like what we can do to optimize it, best practices or something?
Okay. At the moment, the most common way to deploy models is to, and it's, I think, a bit awkward, is that you get to where the model is deployed, you copy the model into the container. Basically, you download the container into your, the model into your container. So this is the long time that it takes to start up, for example, because you have to download the model, fill in the container, then the engine is starting and is loading the model into the GPU RAM. So it's quite long and not the best. There are something that we are working on that are something called model cars. When we pre-optimize a container layer, so we deploy basically the model within a container image layer, and you deploy this layer, it is a bit faster than having to pull the models from an S3 bucket, for example. This is something that we are working on. And I think that there are also optimization in the way you load the memory into the GPU, but I'm not so into that space. So there are something that we are working on, definitely, but yeah.
Something related to that, we also observe frequently that the Docker image itself is really, really large because of the CUDA and everything. And it's usually, in our case, around 18 gigabytes or so. I was wondering whether there is any technique or any more lightweight variant of it, or whether we can squeeze it more than that.
I think, I don't know if at the moment there is really a valid solution around to squeeze this size, because at the moment it's a matter of size. Maybe with VLLM you can compress tensor, you can compress stuff, you can reduce the...
Of course the model, but
when you are...
I'm just referring to the runtime itself. Because this is also an overhead, right? Pulling the image from your registry to your,
it's
your code, it's also some time.
I think that the only way is to try to optimize the way you build the image and remove all the stuff that is not really needed. And I think that the maintainers of the various projects are working to having faster runtimes, smaller runtimes, because it's just a matter of optimization. But at the end, you can't remove the things that you need. So if you have a great image, it's mostly because that you need what's inside.
Right. I'm just wondering whether I'm doing it in a very naive way. And
No.
Doing it in a naive way.
But I think that we are going, as a community, to try to find out a solution or something to improve this mechanism, because it works, but it's not going to scale too much. Yeah.
Just to add to this, I think there was an open source project. I don't remember exactly which one, but that allowed you to pull like the container images from other nodes in the Kubernetes cluster. So that might, like, say if you're running into rate limits with Docker Hub or your container registry, it might be a bit more efficient to pull from a local node than to pull all the containers from the registry. So
Yeah, there are optimization.
Exactly, but it's the one that Microsoft stole and rebranded.
Speculative.
Yeah, Speculative. Yeah.
He works from Microsoft. It's for Microsoft.